All right, we're gonna do something crazy. I'm gonna eat because I forgot that I'd be hungry after the day. But however, while I eat, we're gonna read what this evening is about, which is basically I got a couple of Meshtastic devices, which is like a mesh network kind of thing, and we're gonna basically use LLMs to figure out how to use them, how they work. I already started building a bunch of stuff on using Manus, using Claude, using all kinds of things. I also have a software-defined radio, like a 20 bucks kind of thing that I bought, which we're going to explore. Also already did a little bit of exploring, but not too much. So we'll have a look at that. But first I'm going to eat some chicken, not too much, and we're going to read. I'm going to read. I made two documents. And you know what? Let me link that stuff. Let me link that stuff. Where can I share that actually? What's the best way to share this kind of stuff? I guess I can. God damn it! I don't know how to do that kind of stuff. Because if I paste it in the chat, it will like disappear for people who aren't there, right? Like if I share this, you know what, I'm just going to post it on. God damn it. I don't know how to do this. What could we do to have you all follow along? Well, maybe you'll just have to read at my speed, which hopefully is not going to be neither too slow, or too fast. How do I show both pages? Oh my god, this is such a non-intuitive software. Is it here? Horizontal, odd spreads, even spreads. There we go. So this, yeah, we're going to read this. I have two documents. I've got one about decoding LoRa signals. So LoRa is the low-range radio, which is underlying Meshtastic, which then is going to be like a mesh network protocol on top of it, which I know nothing about. I'm really like, I hate physics, or like, I don't enjoy physics. I never learned much about it. Everything that's like has the word magnet in it is where my, despite having worked in embedded, it's like where my brain just tunes out. Magnets are miracles. But because I have LLMs now, I'm kind of like willing to lean myself out of the window a little bit more in terms of what I might be wanting to learn. And because it's software-defined radio and it's a lot of DSP, maybe I'll have to refresh my math. But then this kind of stuff, Meshtastic firmware architecture, protocol, everything is like packet routing, mesh networks, all of those things. Those are much more my thing. So we'll have a little bit of that as well. And then, maybe I should make a. I'll figure out how to share links in a stream like another day. So I'll let you read along with me, and we're going to read the software-defined radio capture document first, because that's the one I know less about. I got some delicious katsu chicken. All right, hopefully the food is not going to shut my brain off entirely. Um, all of this is like kind of gobbledygook to me, so I'm not sure we'll start with the SDR part directly. Like this section here is what is SF11 long fast preset? So I mean it is a good opportunity to you know to be diving into learning with LLMs a little bit more, which is something that I do pretty frequently, and I'm sure a lot of you do as well. Obviously, the cool thing is that you can just take this thing, right, and then for a lot of you, this is going to be like totally obvious, but also it's like interesting to see for people who haven't tried it using that way. That is always mind blowing, and so that's why I always like try to well share my stuff, but then I love when other people share what seems entirely obvious to them, because then I'm like, man, it's been 3 years. Like, why did you never think of doing that? So, what? And then experimenting with like prompting is always cool, right? So obviously this is really nice as a deep research topic because it's so simple to verify the info, right? It's like all facts. If you do deep research about like philosophical topics, you have like no idea of how much you're actually missing versus reading the actual sources. If you research facts, then you get the same facts back, right? So the interesting part here that I'm curious about is, for example, setting the center frequency. So just to show you a bunch of that stuff, and actually I should close my work stuff as usual, which is a lot of refactoring today. Was like pretty both enjoyable and not. But we'll get into that another day. This is stuff from yesterday. This is from yesterday. This is from yesterday. This is, and then I have already prepared a bunch of Meshtastic stuff. So we'll see. We'll see how these things go. All right. Back to SDR. I guess we're going to do SDR. So apparently there is software called GNU Radio, which allows you to configure basically the DSP that's going to be running, I guess, on the PC itself, right? So it looks like this stuff is usually pretty CPU intensive, especially if you work at like higher sample rates. I've done a lot of audio synthesis, like musical synthesis back in the days. And I used Reactor a lot, so this kind of like speaks to me. It's like one of the domains where I think node interfaces do kind of make sense for like the signal processing. And so in this GNU Radio, the way I have looked at it is you create little blocks here, and then it will code generate either a Python program out of it, or it will generate a C++ program with a UI or without a UI that is going to do the DSP. And the Python library that they use wraps basically a ton of C++ DSP blocks because you don't want to do that in Python, obviously, right? So what I did here is basically I went into the repo and just cloned it and then started using like AMP. I don't think I used AMP. I just like used Cursor to kind of look at it to build it, right? Because there's no build guide, so or like the documentation is not great, and you know, in a way this is like really promising because there's so much you can improve with just a little bit of LLM prompting. Maybe we'll start doing that while we're at it. So let me log out of my work account, which I always forget to do. Log into my private AMP account. And I think I built it, right? Like, I think if I build it, yeah, that's good. So it was funny to see all this stuff that I haven't seen in like years, which used to be my daily grind of configuring like DSP libraries in C++. To be back, I actually don't know where the output is, right? Is there like a GNU Radio companion? No. How do I find the output? Up. Find dot type X. No. Find executables. I'm so freaking lazy. Sbin type F. No. Find executables in local directory. In local directory. Oh, also I created something. If I do Control-Shift-T, it opens a shell in the same directory. So it's type F-executable. Okay. And well, that's not all helpful, is it? Only ELF binaries. How is this an ELF binary? Oh. They are binaries. The fuck? All right, so maybe this is how do I build GNU Radio Companion? Maybe it's a separate repo. So this is the vector optimized library of kernels is like where a lot of the DSP is done. Well, I think that GNU Radio Companion is in here, right? To build GRC, you need PyYAML, Mako, NumPy, JSON schema. So it is GRC. Enable GRC. So let's see if that is true. Enable GR. Enable GRC. Do I need to enable that before? GNU Radio Companion. So do I need to rebuild it? C make D enable GRC. How did this work? How do I enable? I totally forgot CMake how it works. If you want to, you'll need to install additional dependencies. How do I open the README? I won't like open it when I click on this. So it shows me that. And then, oh, I see. Oh my God, why can't I select this? JavaScript. I guess we'll have to read the README, huh? GNU Radio Companion --qt, and then we'll need to install those two guys. All right. Build and run and install as usual from source. Where's from source? Compiling can be found here. From source, dc make install gr from source. Use a local installing dependencies, install UHD, Folk. I already have Folk. Installing GNU Radio. Yeah, I have that. Make dir c build cmake .. All right, so maybe it should work now that I installed the dependencies. Python checking for PyObject GTK found Mako. Enable GNU Radio runtime. NumPy found. Override with disabling GNU Radio support. Enable GRC on. See, I knew it was -d. But configuration checked failed because it needs one of those. Interesting. So that I actually don't even know what those things are. What is GI? If someone knows, no. G-object introspection bindings. All right. I don't know if the Python 3, how do I do it with pip? Can only install Py objects, so we're going to try that, right? GI repository. Is that what I want? It's this one, right? I really need to do like an LLM shell kind of thing. It's starting to bug me. All right, so we're going to reinstall the Python. Hopefully this will work. And we're going to try to CMake again. The reason I'm doing this is just because as I am playing with the UI, I'm going to just like try vibing stuff into it. And just see like this is a big code base, seems pretty baroque. There's a lot of little quality of life things you could do. It has a lot of cool functionality that I really want to learn more about. And we'll see, right? GNU Radio disabled, GRQT GUI, and GRQT GUI. Why is it not finding it? So maybe let's just see how far we can push this. If I just copy paste all of this and say, why no Qt GUI? And I don't feel bad doing this because, I mean, I would scan it by hand. I wouldn't like really necessarily learn all that much doing it. I also really don't care at the end of the day. Let's see, did that help? This would be pretty fun to do this with AMP code, right? So the filter design tool, yeah, we'll do that later. I mean, later, this will do when I have my ham radio license, maybe, something like that. So I've got like the cheapest software-defined radio that I have, but I do kind of want to use the opportunity to learn more about this topic. And I think in this time of like increasing climate change and stuff like that, it is nice to have maybe something that works when the phone network is down or when your phone is not charged. So I have this this little LilyGo T-Echo, which has an e-ink screen. It's I think it's an ESP32. I had a research run, right, like on how the firmware works. So we might be looking at that later on as well. Then I have this like MusiWorks R1, which is based on a RAK and then Nordic, I think, chip. I haven't opened this one. I've opened this one. There's like nothing really interesting in there, to be honest. And then tomorrow, for Prime Day, I got like ESP32 development boards, and so I have 2 coming tomorrow, which is going to be interesting. So you can see I'm in like a pretty unpopulated area of the city, or like, so I only found 9 nodes, but I know you can find more. I want to fly these things on my drone as well, and I want to build like a BBS on top of it, right? Because it's like at its base, it's like a messaging thing, but it's like weird to have messaging on a mesh network where you like don't know if it worked or feedback or is there. I think like the async kind of polling part is like much more interesting. So it did seem that it was able to build GRQT GUI, at least configure it. So we're going to rebuild this. I think I only have 8 core on this machine, so we're going to do this. And most of those are already built because the dependencies were set up. It's a lot of code, right? Like if we start looking at this, it's 130 lines, 300, 400 lines of C++, and then 130 lines of Python. It's actually not that bad. But it has a lot of dependencies and things like this. And if we look at the structure of it, there's like a lot of small submodules. And I mean, I guess I'm going to open this in Cursor as we go. All right. So going back to our just basically being users of this, what I did is I printed out my deep research, but I see that you folks need to follow along as well. So maybe I will move the GNU radio onto space 6. I do have a whole ton of like little fun things to look at that I had Manus build, but that's maybe for another day. Amongst others, a way to help me switch workspaces on stream without making it flash for everybody. Anyway, so looking at this PDF, see, I wonder if I should follow the PDF because I think this is probably not going to be all too didactic, and it's going to garble a lot of sources together and like create these kinds of like very instructive overall because they contain a lot of like facts, but also like this doesn't really tell me how to start with my RTL SDR kind of graph. So what I wonder is like if there are some references here that we could look at. But so this is Meshtastic, right? And then it just tells us, oh, okay, you need to, we are in North America, so this thing is tuned to 915 megahertz. And I think the way that these guys do it here is that you will set a variable. Is that how you do it? Variable? Or they made like a slider, but I don't think we need a variable. So this is, I'm going to call it like LoRa. No, I'm going to call it ISM center frec, right? And then this is 915 E9. I am so bad at this. It's E6, right? Yeah. I don't know if I can zoom in. Oh, you can zoom in, like quality of life. So we have a variable for the center frequency, and then I think I can put in my RTL SDR SOPI source, which is going to be integrated with my hardware when I plug it in. So I might as well plug it in. There we go. Then the sample rate is blah, blah, blah. The RF options is center frec is going to be the real. And then that's about all I know about all of this, right? Oh, it's called ISM center frec. The sample rate, I think, and this is that's where actually the document was interesting. So let me open this in a new tab. To capture such a signal, a sampling rate of 1 megahertz, 4 times the bandwidth, is a safe choice. Even 500 kilohertz BW, what does BW mean? SF11 spreading factor XYZ. So this was SF11. Is that the spreading factor? No, it's not short fast, right? It says SF11. that's what I asked ChatGPT to explain, right? So we might want to have, all right, set the sample frequency, 915E6. The sample rate is, if the Meshtastic preset uses 250, how do I find the preset and what is 11, right? How do I find the preset used by my device and what is SF11? So that we learn something. I really like the fact that this is on stream and recorded because I am learning a lot and I do want to condense that into a learning log, which I'm not able to do because, so usually I have that in my sketchbook where I'll just like take a little bit of notes. I wonder if the act of writing is actually the important part or if it's the notes that I have later on, because I rarely go back to them. But I'm curious to see if like post-processing a video stream and spending effort putting it into shape is going to be interesting because it will allow me to retrace my steps, right? Like reconsolidate the steps that I've been going through. Because I am, and especially for things like, oh, how did I compile the Qt GUI Python thing, right? It's like, I actually don't know. I still don't know where the freaking GNU Radio Companion is, to be honest. GNU Radio Companion XC. It's a script. What does that even mean? Is that the script that you have to run to start it? It looks like it is, kind of. Run main, source tree, check GTK, but I don't have GTK, right? Oh, is the Qt GUI thing just a... No, because it has GRC, right? Oh, I'm bouncing around already. grcc is the compiler. I wonder if this is really like the one to run. There's a Python path variable. Oh, because it's not installed. Yeah, this is for another day maybe. Not doing it on stream because it's not that interesting. So let's go back to just using it. Although I really want to compile it. But who knows? Maybe it's for another time. So we have a little shell here, it looks like, right? Or is this just a log output? I like this part. This is nice. Set the center frequency, set the sampling rate. So we're going to set it to 2E6, 2 megahertz. Start with the gain. So how do I set the gain? Advanced, RF options, RF gain, 30 decibel. All right, yeah, why not? Does this have a little documentation here? No, it doesn't, right? I'm curious to know how this works, actually. So let's open the code and cursor. And then we can ask, like, hey, how does the SOPI SDR work, right? So let's go open this in a folder. Open this folder. Oh, this is interesting. The memories. So we have a SOPI SDR thing, right? And then we have a library folder in here. We do have a source implementation. And so what is SOPI SDR? That is in user include SOPI, which is in the real user include. So SOPI SDR, interesting. App search SOPI. SOPI SDR. What is SOPI SDR? vendor-neutral C++ API and runtime library that provides a unified interface for software-defined radio hardware. All right. RTL, SDR, HackerF. Essential for SDR development when you need hardware-agnostic code or want to switch between SDR devices. All right, cool. Do I want to know how it works? Sure, I'm going to launch a deep research. Explain how the RTL SDR works, both in hardware and software, and how especially SOPI SDR works and communicates with the device. I'm an embedded engineer. Be technical, deep, exhaustive, detailed, I don't know. Deep research, and there we go. Going back to Meshtastic for LoRa reception and our gain settings, frequency calibration. RTL SDRs can drift a little in frequency. A miscalibration of 10 kilohertz can hurt decoding. Use an SDR with a TCXO. How do I figure out what if I do have a temperature compensated oscillator? Which I know from synthesis, actually, from analog synthesizers, where I think things are even more critical, right? It's like the human ear is so good at detecting pitch that any kind of little variation is noticeable. And so if your electronics warm up, your whole synthesizer goes out of pitch. All right, frequency correction using the PPM settings. Is there a PPM setting in here? RF option, frequency correction PPM. All right, cool. And then there's a documentation which only just like links you back to the documentation page. And then this is very, very terse, right? So this is the interesting thing where we can probably do a pretty good job of like, if we go to Sonnet, is like create a better documentation for the SOPI SDR module. And then maybe here, you know, just point it at this folder. Let's just see what happens, right? It's weird because this is like an HTML view and then it just like redirects you to the documentation page. In any case, because one thing that is fun in these kind of settings, right, is that your documentation actually really helps you expand your knowledge while keeping it fun. Since you already have like a dynamic environment here, you can take your documentation and kind of like start messing with the live thing, right? It's like you can click and say like, oh, well, don't you want to try out this example flow graph? And then like this opens like a new tab, and then you can mess with it. That's the kind of stuff that I think is really, really promising, and where LLMs can really help, for example, because it's like a lot of drudgery in a way, right? It's like people who are deep enough into the system don't need it. So it never gets built because someone who is writing the source for the RTL SDR source, they obviously know what RF gain is. And so they won't, even if they want to build documentation, they won't actually know what matters. However, LLMs allow the person that doesn't know what matters to at least ask questions. And these questions, if you were to give the transcript to someone who's more knowledgeable, for example, shows them what the useful information at the end of the day would have been for this user, which is kind of hard, you know, to write down as your, I don't know how to explain it, but these like sessions of learning things, right? Like if I were to come to you and say like, look, I don't really understand LoRa, how does this all work? This already gives you like a lot of insights into what I'm doing, right? It's like, I'm like, well, okay, well, how do I find a preset? Like that's then you could say like, well, let us add that to the documentation, right? And or I can even take the end of the transcript and say like, oh, can you make like a nice step-by-step tutorial to do this? So it says like here, how do I find a preset used by my device? And then if you open the Meshtastic app, and then damn, I'm using my phone as a camera. I really should like change that. I saw this on Amazon today that the Sony Vlogger camera is actually on sale. So it's the ZV-F1, which is $100 lower. ZV-1F. Ooh, I like the white. But it's already even cheaper here, right? Why does it have so much shit in addition to it? $448. This is $448 without any accessories. And then this is $469 with like a shit ton of garbage. Yeah, this is nice, like to... I mean, I don't care about the bags and all of that, but... Does this have good reviews? Is this good? What is the Ag V1 vlogger kit? It's like with a gimbal. Oh, it's not a gimbal. CPS 2-year extra battery kit. It's not available. And then standard accessories. Okay. Additional batteries is always good. And then I like the fact that you can fold it out. All right. I'll check that later. Where were we? It's in the Meshtastic software, so I can't ask it, but I do have, I can connect it to my computer, and then we can look, because I did write. So this is maybe the first time to start looking at the software that I had and like vibe code during the day. Because what I did today, this is where the vibe code part comes in, right? Is I had a Meshtastic TUI getting built, and I wonder if the session's still open somewhere. Do I still have that session? Performance target. Oh yeah. Oh yeah, I do. So let me move that back to a sensible place on the workspace 5. And what you can see here is, let me do a tiled version of it. I have it built like a little Meshtastic tool, which actually turned out to be like a little bit more intricate, because the protocol to speak over serial and like dealing with serial disconnection and reconnection, which seem to happen very frequently. It seems like kind of weird. The Python, after doing like the initial tests on this command line tool that I had it built, I realized like, oh, it's like throwing errors when I connect to it, and it does all of this. It is not able to, like, sometimes it works, sometimes it doesn't, right? Like I would get these errors about some file errors and stuff. And I had it like analyze the Python implementation of it, make a plan for it, then re-implement it in Go, and then just like go through all the different commands and stuff that it was able to do, and kind of then build like a command line tool. So I'm actually going to put this already in my path, because it is quite useful. And I do want to build like a terminal UI, but for the terminal UI, because it is a mesh network, there's like a ton of async stuff happening, right? Like new node appearing, nodes disappearing, sensor readings, messages being sent, all kinds of like sleep mode events happening. So for that, I do want to just build an event-driven system, and I try to have just AMP, the normal one, like a normal sub-agent design one, and that was like just like completely Sonnet over-engineered. So I asked the Oracle, which is a new tool, which is O3 as a planner, and so uh, so we have a callback implementation. I haven't looked at the code of this at all. And yeah, so now we have this like watermill implementation. Let me see what the current status is. I'm going to add the Meshtastic event-driven architecture document to Git, going to commit it as books, add sketch for event-driven Meshtastic UI event-driven architecture. And now I'm going to say in a sub-agent, implement a simple version of this event-driven watermill architecture using a router and the Go channel pub sub. Make a simple REPL. Should I have a simple REPL? I should have a REPL component, actually. That's something I should maybe extract out of, because I have Jesus. Jesus has a REPL. Jesus REPL. Help. Oh, I should wrap the Meshtastic stuff in JavaScript after that. And then I will have a JavaScript Meshtastic library in a VM, in a sandbox. Ooh, that is cool. Keyboard shortcuts. All right, cool. So I'm actually make a simple REPL to wrap it all. And test it. Run in tmux to make sure it works. And we have attached one of the devices. All right, we're going to let it rip. And at the same time, I am going to start a AMP code that is going to extract a REPL as a reusable component. So we're going to use my workspace manager. We're going to create a workspace. And this workspace is going to use Jesus, Boba Tea, which are the two repos that I want. And then I'm going to say extract REPL from Jesus. We have a new workspace manager. We're going to go in there. We're going to go into go Boba Tea, go work use dot. I have a whole branch of, well, actually, I think I added the feature to workspace manager to have templates and to run these templates when it creates a new workspace, but I've never tested it and I forgot how it works, to avoid having to do this whole like go work use kind of stuff. I wanted to find a template for like, oh, this is Go projects, you know, go work all of these. So we're going to run AMP, and then we're going to say extract the REPL TUI from Jesus into a reusable set of models, bubble tea models, in Boba Tea, following the guidelines in Charm Bracelet Bubble Tea Guidelines. Make a test application and also write a full documentation. Once done, use tmux to test and capture screenshots to verify things look as they should. It should be easy for developers to embed a REPL into their own application. And are we going to run this in sub-agents? Use sub-agents and parallel building a liberally. I don't know if that is going to even make sense. But there we go. So we're going to have it in the background extract a REPL so that we can reuse the component. At the same time, this is going to build us a watermill architecture. What we wanted to do originally, though, was seeing the preset, which actually I saw that it already used, right? So if I do the info thing, then I see that the modem preset is long fast, right? So long, slow, and then long, fast. So what's long, fast, right? Using Meshtastic to get the modem preset and the spreading factor. So I wonder if I can get the spreading factor here. Do I get all of it? If I output it in JSON, I don't get all of it, right? What else do we have here in terms of verbs? We do have get. Do we have get? No, we don't, huh? So this would be another thing to build. And I wonder if I should build it in parallel or if I should have merged the task Meshtastic TUI already into GoGo Labs. Or if I should just use the Python version of it, right? So I'm going to rename this to empty or maybe Meshtastic Go. Go, and because then I can do this. Yeah. Okay. So get, right? Meshtastic get. I used this before, so dash dash get. Dash dash get field. How do I get all the fields? Export config. LoRa. Network, power, security, module config, MQTT. Doesn't even have the long fast, right? If I do info, oh, there maybe. All right, this has way more. So it has nodes and mesh, Meshtastic, hardware model. These are the nodes that it found. Preferences, device, position, power, network. Network, it has Wi-Fi. LoRa, spread factor, 0, long fast. So we're going to say, and we're just going to put that in here from Meshtastic info. This is where the video comes in useful, right? Because this wouldn't appear necessarily that I did Meshtastic dash dash info in my ChatGPT transcript. They would just like show the result and be like, "What the heck is that?" But on the video, it will say what it is. It will even have like the screen. Here are the typical parameters for long fast, bandwidth 250, spreading factor 11. So I wonder what the spreading factor is. So what does spreading factor mean? So what does spread factor in the JSON output of Meshtastic dash dash info mean? Notice I'm using 4.0 because I decided to move a little bit away from using 0.3 for everything, just to see, do I actually need this most of the time? I don't know. But only if you're using a custom modem config. In your case, with use preset true, you're using a preset long fast and in the JSON. So the SF is still actually SF11 defined by S. All right, so this means that since we're using long fast, we can actually get away with 500 kilohertz sampling rate, right? To capture such a signal, 1 megahertz, 4 times the bandwidth. So is a safe choice. Okay. Maybe I should pull out an antenna, right? So I don't know shit about antennas. I just have this one came with this like cheap SDR. So I guess we're going to learn a little bit more about antennas. Just going to put it up on my desk. Going to plug this into the software defined radio. And well, I'm missing a USB port because I have like everything's connected now. I do need a hub, huh? Are there some nice hubs for Prime Day? What's a nice one that I can plug in? That's the perfect thing for 03 though. Oops. Nice hub for my desk, for my laptop. Framework 13 with video output 4K and robust and just nice for Prime Day deals. July 2025. All right. And I should have said that maybe I run Linux. Oh, we have a deep research. I didn't actually finish all. Where were we? Now I lost my track. We were trying to understand how something. Oh, we were trying to understand if my RTL SDR has a TCXO. So we're going to continue here. How do I find out if my RTL SDR has a TCXO? RTL SDR, I have the V4. Look for the crystal if you're comfortable opening the metal shielding. Let's open the metal shielding. Because why not? I don't know if I have a precision. Oh, I do have from my cameras. Let me look for a screwdriver because it has these like absolutely tiny screws on it. But thank God from repairing cameras, I have a lot of that shit. I have these like precision Japanese screwdrivers. I highly recommend. They're really nice. They're really nice to use. Just feel great. And then little goblets, actually for chemistry, but I'm going to use that for the screws. So I moved my whole lab to a new location, and I haven't. I don't have shit at home anymore. All right, it's actually pretty tight. So let's see before I nuke my screwdrivers. Holy crap. All right, there we go. Screw number 1. Why are they so tight? That's crazy. Screw number 2. Yeah, I really have to like dig into it. Screw number 3. Oh, Jesus. And then screw number 4. Alright, so how does this come out? We have a little metal piece. Then, this one comes off easily. So then we have a nut and a little spacer, and then the second side of this. Second side of the USB stick cover. We're left with this is fairly nice. This is fairly nicely made for 20 bucks. Feels pretty solid. It's all metal. And then you can just slide it out on a little rail. It's a nice little casing. And then here's the board. And then there's like a little plastic thing to just like isolate it. PCB is interesting with the little metal rails on the side. Maybe I should. Oh, it's because it's green. It's actually catching the green screen. That's funny. Let me go to this. Oh, look at that. Isn't that cool? Anyway, if we look at it, and the light's pretty shit. So they said to look for a 28 megahertz crystal. And I can't see shit. So there's a crystal. There's a 28.8 megahertz crystal, which, I mean, it's on the green screen. It will be like not very visible, but it's this one here. And a TCXO. TCXO may look like this. Okay. I mean, this to me looks like a normal crystal, but alright, this may be worth Googling. TCXO crystal RTL SDR. Building a 28.8 megahertz for the RTL TCXO. Standard SDL and do not come. But we have been selling our own branded dongle, which is the one that I have, ironically. Yeah, as you can see, I have the blog v4, so let me just confirm that this. Oh, I have to switch back to my browser. So this is the one that I have. Let me just confirm that it looks like it's different. I have a slightly different version, I think. Mine is like longer, but it looks very, very similar. Yeah, like most of the layout is the same, pretty much. I do have a second ferrite. I do have a bit more transistor junk around this area. But TCXO looks exactly the same. And I can't read. I see like 28.8 megahertz. And then next to it, there's like a few characters that I'm not able to read right now. and I don't want to pull out my scope, my microscope. So, all right, so we do have a TCXO. That's cool. So I'm going to slide this back in, and I'm going to put it all back together so that nothing gets lost. So let's close this guy using the spacer and the nut. All right. Because if you don't do this kind of stuff immediately, you usually sorely regret it. And I'm kind of someone who's like very, very, what do you call it? Like I stumble. I'm not very agile with my hands or so. So that makes it even worse. I got really good at SMD soldering though, because I did it a lot. All right, one side is closed. Let's do the USB side. And then we're good to go back. I love opening shit, which is because I am not good at it, I break a lot of things. But then I like opening it. With cameras, it was pretty cool because like cameras taught me a lot of patience. It took me like 2 weeks to put something back together, like an aperture iris, and I would put it together and then it would like fall apart at the last minute, and I did that like 2,000 times until I managed to do it, and then I undid it and tried again until I could do it repeatedly. And that was a really good exercise to just like learn to keep your frustration at bay. All right, RTL SDR back together. We have a TCXO, so we don't need the frequency compensation. This looks interesting. I'm gonna put that into my reader list and I'll never read it again. Cool. Two full days to grab. We have the Thunderbolt $400 Thunderbolt thing. Pluggable TBT4. Ugreen Revodox Max. Yeah, but it doesn't even look like the Amazon things. Oh yeah, whatever. I'll do that another time. Where were we? Using an RTL SDR with a TCXO. All right. If you're unsure of the exact frequency band, you can use a spectrum analyzer, waterfall, GNU Radio, FFT sync, or tools like GQRX to scan the expected band. So that's actually interesting. How do I do the FFT thing? Fourier analysis, FFT. Is this the one? No, this is not going to be a UI, right? GNU Radio FFT sync. See, what is this useless kind of... yeah, this is also something where you could very quickly add a lot of things with an LLM. FFT low pass filter. This filter is a convenience wrapper. This filter is a convenience wrapper. Filter FFT low pass filter. And then the FFT Fourier analysis thing is like empty. Right, because here you have documentation. Yeah, so it would be pretty cool to be able to compile this, because if you go into, say, GR filter, right, or GR Fourier, is that GRFFT? Is that one? FFT docs is like a very kind of minimal kind of thing. So we do have FFT VXX, right? Is that the one? FFT size, forward, reverse, window. Yeah, this is it. So, and this would have the documentation, right? It's like if this one was fairly well documented. So does it have additional documentation here for the individual parameters? Oh, so this is the text that comes out of the YAML is shown here, and it's not like HTML. Interesting. Because you could say stuff like that, right? So here it like created, oh, it created the files as well. Funny. I can now create comprehensive documentation. Yeah, and then this is the full-on Sonnet slop. I hate it. Prerequisites. Yeah, this is kind of horrible. Horrible documentation. Needs a better prompt. All right, so create documentation entries in the YAML for FFT tree YAML and other YAML files in that directory. Look at, and then we have gr filter, right? grc, and then say filter FFT root, filter FFT filter. As an example, right? Interesting, yet concise and clear documentation to be shown in the UI. I'm curious to see what that does, right? Like I'm not going to modify the source code here, but this is something where it has GNU in the name. So it's always like, I never try to submit like LLM generated stuff to a project, but man, this is like a perfect application domain, right? Where, I mean, I don't know much about the functionality, and I would probably, I mean, it would be cool to just work with someone who wrote it and be like, you know, let's just use the AI. But I feel so self-conscious because I don't want to get into those debates about like, it's all stolen stuff. I'm like, yeah, but who cares when the documentation comes out? Like also stolen is a weird word to use for like a training corpus of like basically boilerplate code usually. Anyway, yeah, this is nice, right? This is just like nice documentation. Because I think, you know, because it uses this over here, it's able to just like very nicely document it. And of course it's just repeating it, but that's because it's worth repeating it. It's documentation. It's just repeating what's in the source code anyway, right? It just makes it nice to look at it in the UI without having to open the source code for it or so. Yeah, this would be brilliant, I think. And then depending on how much GNU Radio stuff I do and I learn about it, then I will add it. Because and then see, you know, how much of the slop I leave in. Like, is this something that's important to put in, or is this something that's like coming in by default, right? But even more importantly, what would be nice is like, why is this shown as a tooltip where it's like fucking ugly? Also, why is it repeated twice? right? Like it would be nice to have one entry with the short hover over, and then when you add it here to be in the documentation to have like a full HTML page, and then have, because I know there's example sketches in there. I saw them before. There's like under GRC, there's in this one there's not, but there's some in here. I saw that before. There were like example GRC files. Anyway, yeah, there's some here, right? And so it'd be cool to be like, oh, you want demos? Like here's some demos, and you know, we should have like documentation for the demos and all of that. That would be pretty cool. You just have like tutorials as you go. And I think LLMs can like do some pretty good stuff here. It's like write a nice tutorial for the GR filter package based on examples. Store in GR filter examples. And I mean, Sonnet's not going to do a good job because it's loves to write too much code. But with some prompts, that could be something that can be automated. We're already at 120, but the whole point here is to just learn and poke around and get a sense of all these things, because it's not a planned stream. It's just I have time this evening. I want to learn more about my radio shit. So I still don't know how to visualize an FFT, right? So show FFT of input with RTL SDR and GNU radio. I'm using Kagi here. I don't know if that will tell us very much. This is all FFT based visualizer for RTL SDR devices, right? What will you need? Okay, connecting the hardware and software. So what are we looking at here? What is this pretty UI? This is not GNU radio, right? What am I looking at? What was this pretty view here? That's another software, huh? SDR star. Okay. So SDR for FFT viz. How install Ubuntu? I'm just messing around. GQRX. All right. Sudo apt install GQRX SDR. Yes. So we're going to unplug our Meshtastic node, and we're going to plug in our antenna, which I'm going to remove the long cable. I'm going to use the short cable. Oh my God, this is such a mess. All right. And for people who are coming in, I don't know anything about radio. I have no clue what I'm doing here. All right, it's plugged in. We have GQRX SDR running. Or not. GQRX. Oh, GQRX. Okay. What now? That's it? Segfault? Well, that's a good start. That's a really good start. Do I need to run this as root? Oh, it needs pulse audio? But I killed pulse audio the other day. Cubic SDR, nicer features. Why do I need pulse audio for GQRX SDR? I just switched to pulse wire anyway. It's built on top of GNU radio and audio syncs sends audio to your, has historically been, is compiled with Pulse audio support only. What about Pipewire? You're probably running Pipewire Pulse. Oh my God, I hate Linux. This is running. Huh? All right. So GQR input, RTL, that's the one. Bandwidth. Man, they have such shitty UIs. Okay, and now? Configure IO devices. Yes, I did. And then how do I start it? So this is the devices. Yeah, 900 megahertz. Why don't I see anything? I want pretty colors. Do I need to run it as root? Check your device is working. RTL test, RTL power plus heat map. GR Osmos DR plus Qt GUI. Real-time FFT versus Qt GUI sync. Okay. All right. Well, let's see what this does. All right. Frequency. Blackman-Harris. Sample rate, center frequency. And then we do have the 500 kilohertz on each side because our sample rate, no, bandwidth, center frequency. Okay, we do have to test. Oops. So we do have to go back to LoRa, the FFT, center frequency. Do I need to set that? ISM, center frec, bandwidth, sample rate. My knowledge is failing me. Am I supposed to see anything on this? I want to have this like nice waterfall display, right? All right. Show me some parameters for the RTL SDR source plus Qt GUI sync to look at interesting signals. And that's maybe something I would turn on O3 on. Frequency. Sample rate 2.4. RF gain auto. Bandwidth hertz. center frequency sample rate over 2. At the middle of the sample rate. All right, we're going to try that. Sample rate, center frequency. So the center frequency, it's set to put it at 100 megahertz. 100 megahertz, center frequency. I guess let's see what happens, huh? There's stuff. So we can tune it at this point, right? So if I go into the cute GUI range, dial, entry, gauge, label, is it range? Yeah. All right, so this is center frequency. And then this goes from default value 100 E6, start 80 E6, oh no, 88 E6 to 108 E6. And then here in float, it's going to be 200 E3. Widget counter slider, okay. And then here the center frequency. Center frequency. And then here as well, right? Center frequency. Cute GUI range. Auto scale. Fascinating. I have no idea what I'm looking at, but it's cool. This makes me want to have a radio, like a real one. So this is frequency modulation rate. So the audio signal should be visible. The actual audio signal should be visible as like a deviation from the center frequency rate, which the center frequency here would be at. How am I supposed to read this? Yeah. So it would be what, like 989.0? All right, so that's the FM band. That's cool. Can look at the ISM band for like LoRa and stuff. That's like 433 and then 915. So can we even make like a checkbox kind of thing? Can we make like complicated UIs with this? We have label, we have message checkbox, we have checkbox. So let's see. Default value, true, false. Can we do like a select tab widget? I'm just gonna put a few on here. Entry. Chooser. I think chooser is the one we want. So what does this look like? Oh. All right, and then we have the chooser. Where's the chooser? 0, 1, 2. And we have checkboxes, and then we have 2 entry things. All right, cool. So that means that we can, as part of our chooser, maybe. So do we have something that's like called Python block? Embedded Python block. Open an editor. Where's my Emacs? Why didn't it open it? Open an editor. Choose editor. Emacs. The fuck? So it opens it in Z, but it doesn't open it in Emacs. Weird. So I don't know if this is I kind of want to have like a chooser which allows me to select some of these different bands, right? So actually, why not ask it? I want to make a Qt GUI setup in GNU Radio, which allows me to use a Qt GUI chooser to set the range of another Qt GUI range, so I can quickly select one of these bands in the UI, which then sets the values of my range. RTL SDR source sync FFT settings. Let's see what happens. Let's see. It'd be cool if we're able to prompt these kinds of questions. All right. GRC blocks overview, a variable. It'd be cool if we could Qt GUI chooser type drop down band select choices list. Oh, that's so cool. So I can add a variable, right? I can call this band select. Oh no, it's called band dict. Then I make a chooser. I like this. I like this a lot. I understand why people like it. Band select, label frequency, band, type string, drop down. Oh, but it doesn't allow me to do that, right? List, options, list, band dict dot keys, band dict dot keys, default, FM, widget, combo box. Alright, so does this work at all? API block source out not connected. Yeah, this didn't work, did it? Goodbye. Frequency band. Would you look at that? Why it's down here is a mystery. Does it have to do with this? That'd be cool. No. GUI hint. What's the GUI hint? And then you can make, basically, you can just have the Qt GUI frec range, right? Just be like basically default band min. Oh, and then we do need 2 more variables. So variable band min, band max. Alright, so this is band min, this is band dict, band select. Alright. Band max, which is band dict, band select 1. This is all pretty clever. So now we can say default value band min, start band min, stop band max, step 1e6. Okay. Okay, cool. Give me all of the full band dict. And then we also had like the Qt GUI hint, right? Row position in the grid layout 0. All right, let's see. It crashed. Come on. Come on, I hadn't saved. No, 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 no. I hadn't saved. Oh. Oh, there we go. No, what are you doing? What are you doing to me? No, 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 no. Don't do it to me. Invalid UI. Yeah, I know. Okay. Holy shit. GUI hint GNU radio. 0, 0, 2, 1. So if I just do 0, 0, and then I start, and it's there. Cool. And then if I want to display GUI label, center frequency, float, center frec, and then I don't know what the 0, 1, right? love it. There's something interesting here. All right, let's save this. Why is this not possible to like show like the real frequency? Why does it need to like have this as a center frequency here? I don't know. Maybe I don't understand the module either. All right, so this was obviously wrong. And here's the full dictionary. Why does it have these little enter things? What's the problem here? Int numbers options failed. Can't I have like new lines in there? Is that what it is? I guess it is because there's comments in it on a single line. Well, that's annoying. I mean, I wonder if there's like better ways to do this with variable. But all right, what's the issue here? Oh, because it named it FM radio. Default option, FM radio. Okay. Let's go. Wonder what that is. I don't know if that's what we're supposed to see either. If we can zoom in. Yeah, why not blast our computer while we're at it? Alright. FM radio. This is cool, man. What happens if I move my antenna around? There's definitely stuff happening. What does it mean? No one knows. Magnets. Should I even use like 2 antennas? I have this weird double antenna with pretty long 3 feet antennas on it. Is that good or bad? That's another thing where LLMs are pretty cool. You can just ask like the most ridiculous questions, which, you know, if I were sitting at a table with people who were radio enthusiasts, it's not even that I would be ashamed of asking questions like that. Like I have enough self-confidence to be like, I can ask stupid stuff. It's just like, I don't want to waste their time. It's a rabbit ear dipole or a tunable half-wave dipole. It's determined by its total length. The rule of thumb is total length in meter is 143 over frequency. So each length of the dipole, the length in meter is leg length 71 over frec. If each leg is 90 centimeters, then it's like 80 megahertz. That puts it in the low FM broadcast band, which is great for FM, okay for NOAA, and it's not ideal for 400 megahertz like ADSB unless you shorten them significantly. So, smaller tuned whip. Okay. where do I get a smaller tuned whip for LoRa for my RTL SDR search? And there I wonder if O3 is going to be like useful. So I guess this makes sense, right? That I would like receive FM radio on an antenna like that, because it does seem to work pretty well. Meshtastic 915 LoRa whip antenna, Maker Hawk, SMA to UFL. What's SMA UFL? I have a RTL SDR V4. Oh, it actually even says on the case TCXO. So, I mean, it was cool to open it just to see what's inside. But all right, I'm gonna stop in 5 minutes. This has been pretty cool. Like, let's go check what our REPL extraction is doing here, and then what our sub agent is doing building the REPL. I'm actually curious. Where's this hanging? I don't know if it's hanging or if it's just working. I don't know what it's doing in here. I think it's still working. Let's see if it's still working. I do need to go onto a different account. So what is this guy doing? So it's building all of this code. Let me fix all the function signatures. I wonder if this is still running or if it's like reaching the end of its rope. We'll see. We'll check back on this guy. Or I'll check back because I probably have closed this. All right, what is it? Deleting? I should have checked in more often to just like acknowledge the tools that this guy's running. So we're going to wait until the REPL part is finished because that would be pretty funny to look at. Is this guy continuing to do its stuff? Yeah, it is, right? Yeah. Yeah, okay, so this is still working. But it reached its context window length. I think this is kind of like the shit it does when it starts to forget about the stuff it wrote. It's like removing main things. This is going down a bad route, I think. This is annoying. I should have done this in a main thread. I knew it. Yeah, because it's like, how many mains has it gone through? How many adapters has it gone through? Like, none of this is great, I think. I mean, YOLO. Excellent. The build succeeded. That's crazy. Sheer will. Sheer will. Okay. So SMA female connector, threaded outer shell, sender pin goes into the device. This is not the same as the cheap dongles with MCX or PAL connectors. You need antennas or adapters with SMA male to plug into it. Okay, and then UFL is this like little little thing that you clip on. I love the emojis. What the heck? Oh, this is so hilarious. Okay, so I do need this like Meshtastic whip, which is, come on, where are you opening this? Yeah, $10. You know what? And then, so that means that I should actually be able to use that, huh? Oh shit, this thing gets hot. All right, I've connected the 950 watt whip, which the FM goes away significantly, so that's cool to see. And so now if I go to the ISM 915, I should be able to see more interesting stuff, right? So how can I want this FFT to run more often so that I have like more resolution in the time domain. So this is 915. It's only when it's at like 92 that I see stuff. Oh, it's because my sampling rate is 1 megahertz, right? So I do pretty big jumps. So if I set the sample rate to 2.4, which is what they were saying this thing supports, and then what's the issue here? Is it too high? Oh no, I can run it. Wait. Oh, it went to another device. Okay. So now if I go to the LoRa ISM, and then here I should be able to see. If I go to 32K, yeah, so this is the center frequency, I think. 915. I have trouble reading what this is down here. So is it this dude? I don't know how to turn it off. So this is when I put my hand on it. This is when I move the other dude close. Definitely something's happening if I move it closer. Then I think it's turned off. Bro, I have no idea. That's cool though. I wish there was like more resolution in the time domain. What did I do to change that? Oh, I can zoom like this. All right. Yeah, man, this thing gets hot. Crazy. All right, well, I have no idea what I'm looking at, but it's pretty colors, and changing the antenna did do change something. But let's go back to something I understand a little bit better. LLM programming. So I should have said use tmux to test it, right? But it doesn't use tmux. We are in Meshtastic, so we can do run command apps, Meshtastic, and then command mesh REPL. Cool. Cool. I'm disconnecting I'm reconnecting the Meshtastic device. Haha. All right. So removing the handler, I'm going to make a list of to-dos. To do MD is crash when re-listening, listening twice, need to remove handler. So that was one. Connect. Connect should go into the background. Should return, right? All right, so the usual suspects. Connect is hanging. Control C should kill the router. Watermill. which we're all gonna look at another day. I knew this would be like a little bit too much all at once. I should have I should have been less aggressive, but I think there's enough boilerplate to actually salvage that. And then here, this guy is writing a comprehensive documentation. So this guy, I think, is in my M code. If we go to the threads, extract REPL TUI, and then all the way to the end, this guy is writing documentation. Why is it so slow? Because it's been at it for a while. It's been like reading stuff. Because now it's writing this this document here, huh? So I kind of want to wait on stream for this to finish, just to see if it worked or not. In the meantime, what we can do is, so this was a pretty successful experiment. I don't know how to build it from source, but there's a lot of little quality of life that can be done. In terms of documentation, for example, in terms of tutorials, and that was pretty fun. Also, interpreting what's coming out of it would be pretty fun too. What is a two-way LoRa signal booster? I don't know shit about this, so I'm not gonna start. Is it hanging here? I wonder. All right. FFT-based visualizer. So we already got pretty far now with our visualizer, right? We tried GQRX, which crashed or wasn't really doing much. Then we have SDR hash. And then so the IQ data is something I want to understand. That's like the complex data coming out of the device. Yeah, I didn't see all of that, right? Like I didn't see a start stop button. All right. I think this is stuck. I think this is just stuck. Continue to dock. The extraction plan. That's interesting that it made it in Mermaid. I wonder if they picked up my using Mermaid for planning technique. Interesting. So what is this dude doing? Writing a new documentation, right? Like a second one. So it doesn't live update, even though it makes like a little floaty thingy here. Yeah, this is cool. This is cool, man. Because I extracted a command palette into Boba yesterday, and now we have a REPL component as well, and maybe we can combine the two as well, which would be pretty fun. And that would make it pretty nice to add like REPL functionality for a lot of like tools that you build, where instead of going into like a command line interface, you can start just like mixing things together. I like that. So we were in this directory. So if I go into Boba and then I go into command, and then I can do go REPL demo, and I can do a math REPL. Yeah, that doesn't really work, does it? The open an editor. Because the REPL's still running. Okay, fun. How long is this going to take here? What is it doing? All right, in the meantime, so we learned quite a few things about the Meshtastic a little bit. This was debugging earlier on. We didn't look at the protocol, right? But how far did we get in 2.5 hours? I think we got pretty far. I printed this out, so I'm going to look at this in the morning. Open source programming. So now I'm going to say make TOC for a open source programming Meshtastic book. 10 chapters. This is the firmware. This I printed out. About the firmware itself, we looked at frequency drift, looking at the oscillator, so that's cool. We did that. We opened the device. We didn't go very far in this document, but we learned quite a bit, right? Like just playing around with it. Look for a distinct sweeping signal when a Meshtastic node transmits. And so it appears on the spectrum display as a broad waveform that rapidly sweeps frequencies. These are the chirps. So this is something we'll have to investigate potentially, right? The band range is from 902 to 928, long fast. The standard preset long fast provides 104 frequency slots. After factory reset, the radio defaults to long fast with a frequency slot of 0, which translates to slot 20, centered at 906.8, based on the channel hashing algorithm. So it's not what we were looking at. Bandwidth 253 megahertz. All right. Is it still writing the docs? What is going on? Is it hanging as well? Oh no, it's editing the README. But is this just a repeat of the docs? It's like creating more examples. It is getting a bit sloppy, my friend. A bit sloppy. All right. TCXO, we looked at that. Looked at like Thunderbolt. Docs. Oh, so this is the deep research we started about how the RTL SDR works. So let's have a look at this PDF, which I'm going to print for my morning magazine, right? Except it didn't download anything. 34 kilobytes. Okay, that wasn't good. Why is this broken? Oh, interesting. I've never had that before. Did it just delete it? Oh no, there we are. That's weird. Never seen that before. Never seen it. So this would be a markdown file, which we're going to go into a vault. So we have today is the 7th RTLSDR.md. And then do we still have the pandoc? Yeah. Open PDF. Magic. Alright, this looks actually reasonably close to what ChatGPT itself is doing. Except I have colors. Alright. This is for my morning magazine. And... oh, is this done now? Is it still creating more examples? What is this thing doing? REPL custom theme. This is going like all Sonnet. It's like going all in. PKG REPL examples? No. Where is it creating all of this stuff? Examples REPL. Embedded in app. Jesus. Yeah, it doesn't even compile. Like, stop it. And then we can do go run. Go run basic usage. That compiles. Alright, cool. Go run custom theme. Yeah, just stop, man. Theme switcher app. Cannot use app REPL update message value of interface type T model as REPL model value in assignment need type assertion in main.go. That seems like a fairly simple one to check. Yeah. I'm gonna have it correct that one at the end. Oh, it's actually already going to do that. Okay, cool. Yes. So telling Amcode to use tmux is great because then you can test like all kinds of graphical programs or like terminal programs, but you can also like tail log files at the same time. You can do all kinds of like clever stuff. All right, anyway. I am getting distracted by my Slack. All right. And it's done. It finished it. I don't think it fixed that one, right? So let me see if it's able to fix that one. Fix in sub agent. And that would be pretty good. Let's see. Let's see. What's going on Twitter? Nothing's going on Twitter. All right. All right, running tools. Is it fixing it? Like, I mean, we can test it here. Yeah, now it's fixing demo, colors, rainbow. 1, 2, 3, 4. Oh my God, this is this is amazing. I love it. Oh my God, this is so cool. I'm glad it actually created that example. So what was the other one that was not working? Embedded in app. So we're gonna fix that one too. Yeah, because the other one has been fixed, right? So there's a lot of slop here. Like, I don't need the full JavaScript here. But I mean, still cool that it has ported it, but I don't need it. I don't need to bundle the whole playground in here. This just looks like a lot of slop that it created while doing all of this, right? So we're obviously going to add package REPL. We're going to add examples. We're going to add docs. And then we're going to add REPL demo. There's a binary in here somewhere. Where are you hiding, you little binary? There you are. Yeah, there's a lot of readmes. There's a lot of duplication. So that's the downside when you have agents and when you kind of like don't look too closely at them, right? Because there's say the evaluator for JavaScript. I don't really need it. I don't know what there's like another example in here. Like you can tell, this is the kind of slop where you need to pretty quickly crack down on it. I made a mistake of like vibing on the same repo for like 3 weeks, letting all that stuff accumulate. And I learned my lesson. which is a little bit of cleaning would have gone a long way, right? And like actually, this is something that would be interesting to look at. It's so if we do take this, right, and then we ask the model to assess what is duplicated and what could be removed. So the embedded in app, though, I do want to run this first. So examples, REPL, embedded in app is now working. Holy shit, this is so cool. All right, we're going to commit it. This is so cool. I'm actually a little bit impressed. We will have to remove things, but add REPL functionality and widget, left hook 0. Okay, we have quite a bit of repetition and slop in our latest feature. Make a plan using the Oracle on how to clean things up. Right? Store the plan in cleaning up after building the REPL.md. This is something I've never tried either, but I'm going to more and more just like be trying this kind of like menial code cleanup stuff and like let it run, like maybe even in a cron job where I say like, oh, go over the repo and just find like documentation that could be improved, or documentation that's out of date, or like examples that could be predified, or like make plans for refactoring, like those kinds of things that I can then review and just I don't know. Pretty cool. Here, the simple event-driven watermill architecture is now done, but I think it's going to be significantly broken. I don't know if I want to go more into this. I also said that I would stop a long time ago, because if I do this, it will hang, right? Shutdown signal received, and then it just like hangs. Okay, so that's a bigger thing. I would like to look at the architecture of all of this. I am, however, going to commit it. Meshtastic command mesh REPL, and I really need to put into my agentmd that it should make a build directory, so I don't have binaries everywhere. All right. Add event-driven architecture. It's also a poop because it doesn't work all that great. Add event-driven architecture to Meshtastic REPL. And we're going to push it. Important, I forget to push as well, which is not the best thing either. I wonder what this guy's doing. This was the REPL part, right? We have quite a few duplications. Analyze the REPL. Read simple embedding, thinking. I should use the Oracle, so it's actually not showing much from the Oracle, or the Oracle is hanging. No, it finished the plan, right? Comprehensive cleanup. One canonical REPL. One authoritative sets of docs. One demo binary. One example tree under examples REPL. No stray build artifact or temporary scratch directories. Rename boba t command REPL demo to boba t command REPL. delete command REPL examples. Examples live in examples only. Trim main.go to a thin Cobra wrapper that delegates to the PKG examples. Move math evaluators into this. Yeah, this is cool. I like this. Does it use auto for the JavaScript? I don't know if it's a good example to keep in there though. Maybe I should. All right. Implement the plan. All right, I need to finish the stream. I said I would stop like 40 minutes ago. This was from yesterday. I could continue forever. This is like the horrible thing about this is because then I leave with these half-finished project. Like the mesh REPL is so close to being useful, right? But it's like probably a day, an afternoon of work. And is it really what I should be having right now? Is it just like a shiny little object that I want? It's a good question. But in the way of doing that, we actually have extracted a command palette. We have extracted a REPL. We have done all of these like little things that do add up over time, right? To a pretty rich ecosystem. Because I had built it, I started in labs, or like in my MCP folder, built this like JS server MCP, vibed a REPL to it, then moved it to labs, made a new REPL and called it Jesus, extracted it to its own repo. Now I'm taking the REPL component from Jesus, which has grown over time, into its own package, where it's going to be able to be easily used, because as we've seen, switching the themes and all of that was like, all these demos were pretty nice. So now we have something to reuse quite a bit in other contexts. And yeah, this all like fairly quickly. I mean, I have like 300 projects by now that I've, since my vibe coding journey. LLM programming journey, more like. And it's so easy to lose track of like, did I do something useful or not? But it's like all of this stuff kind of piles up, right? I mean, those are like the messy ones. Like maybe I should go, Porca is like not worth continuing. I should kill it. There's a bunch of stuff that made sense in the early days of LLM programming, or even more so in like the previous days of programming, which are just like not a good API target anymore. But I think the next big thing to focus on is how to deslopify and how to handle documentation and how to handle plans as these things grow in longevity, right? Oh, I remember that I have like this new help system as well, right? I do have this like UI help system. Oh, I completely forgot about that one. Because that one works actually really well. I did spend some time adding that. Holy shit, I forgot about this, which means that if did I merge that? Yeah, advanced query DSL. That's right. It has like a full query DSL. I totally forgot about this. This is crazy. This is crazy. I should publish this, right? I totally forgot about that. Which means that if I add it to Pinocchio, then I will have this nice little graphical browser and the query DSL for Pinocchio and for Geppetto, and that allows me to search much more easily for my entire documentation stuff. That's crazy. I forgot about this stuff. Because if I go into Pinocchio, and I bump glazed, and then I do go run command Pinocchio help dash dash UI. Go can be slow when you have 30,000 packages to compile. I hope I didn't break too much either. What is it doing, bro? Okay. FTS5 support UI mode not available? What does that even mean? That's hilarious. Okay. So that part works. Query. Type examples. Oh, it's type example. Why does the UI mode need to be? What am I doing? I should stop. Yeah. All right. Thanks for watching.